I'm Professor Mrunal Bakane. I'll be explaining you how to find out the modulus of rigidity of a wire by torsional oscillation. Now here in this apparatus we are going to determine the modulus of rigidity of the wire by torsional oscillations. So what you see here, there is a wire here and one end of the wire is fixed to the rigid support and to the another free end of the wire a disc is attached. This disc is attached to the free end of the wire. Now this is a screw with the help of which we can loosen this and the different lengths can be adjusted. First of all, what we have to do is we have to take the mass of the given disc. You have been provided with the weighing balance. Put this disc, remove this disc, keep it over here, you get the weight of the disc, note it down, mass m of the disc. Another thing, we have to find out the diameter of this disc. To find the diameter, we use the vernier caliper. Now, we should know the least count of the vernier caliper first. Find out the least count of the vernier caliper and now see how we find out the center of the disc. Attach it like this, fix it like this with the help of this sliding screw and remove it. Note down the main scale, vernier scale, multiply it by least count, you get the diameter of the disc. Measure the diameter of the disc at 2-3 different places and note down the diameter in this tabular form. Once you find the diameter of the disc, divide it by 2, you get the radius of the disc. So what we have done, we have found out the diameter of the disc. To find out the diameter, we use the vernier caliper, find out the least count of the vernier caliper, note down the diameter and hence find the radius of the disc. Now we have to find the diameter of the wire, given wire. So to find the diameter of the wire, you have to hold it like this. Take this wire between these two prongs and remove it. Note down the main scale, circular scale, multiply it by the least count, you get the diameter of the wire. Enter the diameter of the wire in the next tabular form and divide it by 2, you get the radius of the wire. So we know now the mass of the disc, radius of the disc, and the radius of the wire. Now we actually perform the experiment. Now here what we do, we give this disc, start with particular length. As I said in the beginning, this screw can be adjusted, either you can do it from here or loosen it from here. Take a particular length of the wire, suppose we start with the length 20 or 25 centimeter. Loosen this and make it 25 exactly by measuring with the scale and then tighten this screw. Now whatever length is there, I will perform for that length, but you have to do according to the instructions, whatever length is asked in the experiment. Give it a small oscillation. As soon as we give it the oscillation, torsional oscillation to this, we have to start the stopwatch. Okay, so keep the stopwatch ready and give it a small oscillation. While giving the oscillation, take care that oscillation should be in a horizontal plane. It should not wobble like this. Okay, so I give it a oscillation now. Start the oscillation and count the time taken by the disc for the 20 oscillation. Again, when to count the oscillation as 1, when it goes to one side, come back to other side, it is counted as oscillation 1. Now, there may be a difficulty in noting down which point to see on the disc. So what we do is, we do some chalk mark or something in front of us on this, whatever part of the disc is facing us, we make a chalk mark and again I show, suppose this is the line there. So I will be focusing every time while counting the oscillation on this line only. Give it the oscillation. Stop it first. Again we repeat. Start. 1. Going that side. Coming back. While coming back, when I am focusing on that like 2. Going and coming 3. Like that. Let it go for 20 oscillations and you note down the time for the 20 oscillation. So for the particular length, for the number of 20 oscillations, what is the time taken? That we note out in the third table, which is the table for entering all the oscillation for different lengths. So for the particular length, we have taken down the time t of oscillation. Now for the same length, we repeat the experiment 2 more times and then find the average speed, and hence we find the time period capital T, which is equal to small t by 20. Now this was the story for one particular length L equal to 20 or 25 centimeter. Now you go on changing the length by 2 centimeter or 3 centimeter. Then suppose we have started with 20, then next we take a 25. So loosen this screw with the help of scale, make this wire length as 25 and accordingly tighten this screw. Repeat the same procedure, give the torsional oscillation to the disc, measure the time for the 20 oscillation and hence find the time period capital T. Like that you have to take 5 to 7 readings. So after taking the different lengths and finding the time period, we have to enter all these readings in the tabular form. Once we enter it in a tabular form, we get one column for the length, another column for the time period T, and the last column now we make for L upon T square. Once this is made, we can find out the modulus of rigidity using the given formula. Now, before that, we require to find the moment of inertia. Now, moment of inertia is given by m into r square upon 2. Now, we have to find out the mass of the disc. So, weigh the given disc on the weighing balance, we get the capital M value. R, radius of the disc, we have already found out. Small r, radius of the wire, we have already found out. So, now we can find the moment of inertia of the given disc as well as we can find out the modulus of rigidity of the given wire. Now, once we get all these observations entered in a tabular form, we can draw a graph between L, capital L and T square. The graph is a straight line. Find the slope. That slope is nothing but L upon T square. So, once again, we can find the modulus of rigidity from the graph. Earlier, we have found out by observations. Now, we'll find out from the graph. So, we have 3 calculations here. One calculation is for moment of inertia, one calculation is for modulus of rigidity from the observations, and one calculation for the modulus of rigidity from the slope of the graph. And hence we get the modulus of the rigidity of the wire. Enter that in the result form by graph by calculation. Thank you.